Good morning, good afternoon, good evening. Welcome to Chapter 17. Remember, we are doing the survey of life. And that means that we are looking at all groups of living things. And the strategy that we're using for looking at the living organisms is least complex to most complex. Remember the last time we looked at bacteria and protists. Remember that there are three domains of life. The three domains of life are domain bacteria, domain archaea, and domain eukarya. We talked about domain bacteria, we talked about domain archaea, we're now in domain eukarya. Within domain eukarya, there are four kingdoms. Let me take a second and back up and talk about this thing of the hierarchy, the classification. Remember, we said that a domain would be like a continent. There are several continents on the planet. Which one do you live on? You live on North America. How many countries are on the continent of North America? There's three countries: Canada, the U.S., Mexico. All right, so domain is like a continent. There are three of them: bacteria, archaea, eukarya. Well, you live within domain eukarya. You live on the North American continent. Within the North American continent, there's three countries. Which country do you live in? You live in America. Within domain eukarya, there are four kingdoms. And the four kingdoms are plants, animals, fungi, and protists. And we talked about protists already. And now we're going to move on today, and we're going to talk about plants and fungi. Within the U.S., there are lots of states. Within each kingdom, there are lots of phyla, lots of groups. And so we're going to talk about the different groups of plants. Plants, about 500 million years ago, remember at the end of Biology 1, we talked about the history of the world, and we said somewhere around 500 to 600 years ago is when life finally came out on land. There wasn't any life on land before then, and the first things to come out were probably plants. Algae colonized shallow water habitats, shallow freshwater habitats. Some of these algae, remember we looked at brown algae, we looked at kelp in the previous video, and remember how we said, look, this thing looks a whole bunch like a plant. So it doesn't take a whole lot of changes to turn this very complicated protist into a simple plant. These algae, like kelp, colonized these shallow water habitats and accumulated adaptations that allowed them to exist and live permanently on land. Those complex algae gave rise to modern plants. Why would a plant want to live on land? Why not just stay in water? I mean, let's think about it. Plants need lots of water, right? Don't plants have to be watered all the time? Why not just live in water then? Why not just stay in water? What is the advantage? What's the benefit to coming out on land? And the first and primary benefit is that there's more light. Water does not transmit light very well. It depends on how clear the water is, but after about 10 or 15 feet down, the water intensity, let me start over, the light intensity. The intensity of the light is too dim to support photosynthesis. After about 10 or 15 feet down, depending on the water clarity, you can't really, certainly in freshwater habitats, the light is not bright enough to support photosynthesis. And so what we're doing then, what we're saying is, that means that there's only a very limited space. Just around the edge of the shore, is there enough space for totally aquatic photosynthesizers to live? And where there's this huge land mass where plants could cover, where they'd have access to way more light, and the light would be way brighter. And remember, photosynthesis, that's how plants make their food, so they want lots of light. So there's a lot more light on land. There's also a lot more carbon dioxide in air. There's not that much carbon dioxide in water. Carbon dioxide does not dissolve in water very well. And again, what are the three things that a plant needs to make sugar? They need light, they need carbon dioxide, they need water. Well, in water, the light's not that great. We just said now the carbon dioxide isn't that great. On land, we totally solve both of those problems. There's tons of light and there's tons of carbon dioxide. There's also a much more reliable source of minerals. If you live in water, the water dilutes the minerals. Iron, calcium, vitamins, stuff like that. If you live in water, all of those minerals are diluted within the entire water body that you live in. But if you live on land, there's a source to replenish those lost nutrients, and it's called soil. The rocks that are on the soil, the dirt that's in the soil, all the stuff that's in the soil will replenish those lost, basically, plant vitamins. Much more reliable source of nutrients, of vitamins and minerals on land. And think about it in terms of nothing has come out on land yet. So then there's not any predators on land. And I know you don't think about, like, a cow or a caterpillar as a predator. But to a plant it is. To a plant, a cow is a predator. A horse is a predator to a plant. So if there's nothing on land yet, because there are no plants, it's nothing but dirt and rocks. When these first plants come out on land, then they're escaping the only place where there are predators, which is in the water. And so if they're escaping predators, that's another reason for them to come out on land. There's more light, there's more carbon dioxide, there's more vitamins, and there's nothing to eat them out there. Wouldn't you want to live somewhere where nothing can eat you? Well, plants wanted to live where they wouldn't be eaten too. So they came out on land. Well, as with anything, just because there are benefits doesn't mean there aren't problems. And there are actually some fairly significant problems to come out on land. And the first is, well, there's no water. Well, there's very little water. If you live in water, surrounded by water, there's lots of water. If you live on land, specifically if you're a plant, there's no water in air, or at least not enough to support the plant. So the only place to get water is from the ground, and water doesn't stay in the ground that long. It moves, it dries up, it evaporates, and so there's not a whole lot of water. So that's the first problem. Well, how do they get water? If I'm surrounded by water, I don't have to transport it. If I'm living in air, now I have to transport water. And the second thing is they've got to deal with this thing called gravity. In water, you don't have to deal with gravity. Water supports you. So if you don't have to deal with gravity, you don't have to have rigid structural parts. If you were to take that kelp that we saw in the previous chapter, and we were to try to make it stand up on land, it's just going to fall over, like a rope. You can't make a rope stand up, it's going to lay down. Well, the rope will stand up in water. It won't stand up on land. So you have to come up with a way of beating gravity so plants can stand up right. And the last is gamete dispersion. And we talked about gametes in Biology 1. Gametes, remember, that's the blanket term that means sex cells. It means both sperm and egg. If you live in water, it's really easy to have sex. And that is that the female just releases her eggs wherever she is. And then the male nearby just releases his sperm. And then that's it. The sperm can swim to find the egg, and bam, that's sex. Really easy to do if you live in water. Not very easy to do if you live on land. If the female just releases her eggs wherever she is, splat, there they plop on the ground. And if the male just releases his sperm wherever he is, splat, there it goes, plop on the ground. And there's no way for the sperm to make it to the egg. So you've got to find a way of spreading, of getting the sperm and egg together. And that's difficult. It is a problem on land. It was something that had to be solved. The way the plants fixed the water problem are these things called roots. Roots anchor the plant in the ground, keep it from falling over. The roots are also absorptive, which means they will absorb water. It's the job of the root. The root has a few jobs, but the main job of the root is to absorb water. It's to suck water from the ground and then give it to the plant. Well, that's great. It drew water up from the ground. Super. Now it has to get it to the top of the plant. How is fluid transported around your body? It's transported around your body in little tubes. We call them arteries and veins. But these tubes, it's their job to be the transportation system to move everything in your body. Plants need that too. And in water, they don't have to have that. They don't have to transport anything because they live in water. Everything they need is right there. They don't have to move anything. If you only move stuff, if it only has a source of it in one area and I need to take it somewhere else. If it's just everywhere, I never have to move it. Now living on land, the water is only in the soil. And so that water has to be moved. And so plants had to develop vascular tissues. These vascular tissues are a transport system. And just like you have two types of vascular tissues, so do plants. You have arteries which carry blood out to your body, and you have veins which carry blood back to the heart. Plants have xylem. Xylem carries water and minerals from the roots out to the leaves. And plants have phloem, which carries sugar, because remember, the leaves are doing the photosynthesis and the leaves are making the food. The phloem carries sugar made in the leaves down the trunk and down into the roots. Remember, the roots are alive. Living cells need food. The trunk is alive. Living cells need food. So all of this food that's made in the leaves has to be transported to these other areas of the plant. They have to be transported to the trunk, and they have to be transported to the roots. And that's where these two vascular tissues come from, xylem and phloem.